Hi, welcome to another lecture on business mathematics. Today we are going to talk about linear functions and equations, graphing, and word problems. So here is a selection of problems from your textbook. I'm going to solve problems somewhat similar to these things, not exactly the same problem that are your homework. Before we get started, what is this f of x here? That is notation for a function. We are going to talk about that in the next lecture. For now, just to make it easy on yourself, think about y is equal to 2x minus 1. So problem 21, what it means is just that you graph that function, find the slope, intercept, x-intercept, y-intercept, if any of them exist. Okay, so f of x just placeholder for y. So let me take a simple example. So suppose I have y is equal to 3x minus 2. We want to graph this, find a slope, intercept, and so on. First of all, this is the multiplier of x is the slope. So slope is 3. Typically, the letter used to refer to slope is m, perhaps for the word in French, but it's traditional to use the letter m. You also might remember that this is our y-intercept. Y-intercept. Now let's go ahead and actually understand what this thing means on while we are trying to graph this thing. When we want to graph this thing, one of two things can be done. One is we start from scratch as if we have never seen this thing before and graph it that way. And then we want to summarize and have a quick way of graphing the equation that we have. So if you have never seen graph of a function before, and we have no idea what it looks like and so on, we make a table. So the first line of attack is to make a table for our variables, commonly referred to as x and y, and we try to fill in this table as much as we can, as much as our patience allows. We try to find these things. Either we give a value to x and find y, or give value to y, find x, whatever that works. Here it's very easy that if you, for example, give x the value 0, then 3 times 0 minus 2 will be just minus 2. Now, this being our first line of attack, we are going to go after numbers that are easy on us. So after 0, we think about number 1, but really there was no reason to skip on 0.5 and so on. Simply for our own convenience, we pick on these friendly numbers. So if x is 1, we say, well, what's y going to be? This is the equation or the function is giving us a recipe. 3 times 1 minus 2. So now it is 1. And then when x is 2, 3 times 2 is 6 minus 2 is 4, and so on. And then again, if we have patience, we go ahead, find halfway points, and so on. When we want to graph this thing, well, we draw our x and y coordinates systems. We choose a unit on x and y so that our picture is going to come up looking large and readable. So with this kind of numbers, for example, I make a judgment that this is a good size for R1. If you make it too small, the picture will not be legible. If we make it too large, then, well, things won't fit on the page. So right now we have the point 0 and minus 2. This is x coordinate and y coordinate of some point. So this is going to be minus 1, and therefore this is going to be minus 2. So this is the point 0 and minus 2. 1 and 1, 1 and 1, so x is 1 and y is 1, so 1 and 1 is easy. 2 and 4, so I'll go 2 units and then 1, 2, 3 and then 4, so I have the point 2 and 4 here as well. That is my other point. Well, we are taking a leap of faith by just connecting these points. Why leap of faith? Well, because I didn't fill in between these points, so we are kind of assuming that the picture is going to look like this. This is going to go connect to that one, and then hopefully connect to that one, and so on. Well, this is called the linear function or linear equation because the graph of it looks like a straight line. So mine doesn't look very much straight, but the graph of this thing is a straight line. One thing that we notice here is the notion of slope. On the picture, we see the slope itself. So the slope is, if I increase x by 1, y increases by 3. So if x increases by 1, y increases by 3 units. This is 3 units. Here again, if I go 1 to the right, then I go 3 units up. So for each, it evaporates. Funny. So that's the meaning of slope. For each unit forward, how much do we go up or down? So if the slope is positive, we are going up. If the slope is negative, we are going down. If the slope is 0, we just stay flat. Well, what if I take 2 steps? So if I take 2 steps to the right, then I have gone up by 6 units, and so on. So that is my slope. This is the slope of my line. This is, of course, referred to as the y-intercept. Y-intercept, when you write your equation in the form mx plus b, if you write it like that, then m is the slope and b is the y-intercept. That's what we saw last time. So if you write y is equal to mx plus b, this, remember this thing, this is slope, and that one is your y-intercept. Well, let's dig in a little bit more. How do we actually get y-intercept? Y-intercept, if you set x equal to 0 in any equation, the y that you cover is going to be the y-intercept. So the recipe that's more general, not necessarily for a line, but later on you might have something more sophisticated than a line. You want to find the y-intercept of it. You put x equal to 0, recover your y, and then your y will be, that's going to be your y-intercept. So here, this is the point with coordinate x is 0, y is, minus 2, y-intercept is minus 2. How about the x-intercept? Where is the x-intercept? Well, x-intercept, as the name implies, is where to hit the x-axis. So how do we find that? Well, when you say x-intercept, you said it hits the x-axis. So when hitting x-axis, it means the y of it is 0. Y of any point on the x-axis, the y of everything on this is 0. So that is our clue. We say if y is 0, what is x going to be? So we solve that equation, take the 2 to the other side, and divide. You should be able to do that quickly. You get x equal to 2/3. So that's going to be your x-intercept. X-intercept, so this point is the point 2/3 and 0. So we have answered all the questions for this one. Now let's go take another example. Like what? Like what if our numbers are a little bit unfriendly, like fraction, decimal, and so on. So some practical issues come up. What do we do in that case? So for example, let's go take a look at problem 25. So I'll have, let's go back to the white here. So I have, again, instead of y, instead of f of x, let's write just 2/3 of x plus 1/3. Now the issue is in this problem is that our numbers are not as friendly as these whole numbers. Other than that, the problem is exactly same as before. So as far as answering some of the basic questions here, so we can say the slope, we have that one, because our equation is written again, if it's written in the form mx plus b, y is equal to mx plus b, your m is a slope, so this is slope 2/3. Your y-intercept is going to be the number that's added, so that's going to be 1/3. And then if you want to find the x-intercept, we said the idea of x-intercept is that the y is equal to 0. So that is for the x-intercept, y is equal to 0. If y is equal to 0, therefore 2/3 of x plus 1/3 has to be 0. So that means 2/3 of x is going to be equal to minus 1/3. So when something goes from one side to the other side, if it is added, then subtract it from the other side, or just go ahead and do as you do in high school, which is subtract 1/3 from both sides. Multiply by 3, so we get 2x is equal to minus 1. Divide by 2, so x becomes minus 1/2. So here's my x is minus 1/2. Now, what if you want to graph this thing? The issue is just to be as careful as possible with representing these fractional numbers. That's going to be a little bit tricky. So here I draw my lines. Now notice what happens. If you say this is my 1, first of all, even that is hard to see. And then you are supposed to find out where is 1/3 of that. That becomes the issue becomes a lot harder. So how about taking 1/3 and marking that? So that's going to be 1/3, 2/3, and then 3/3. This is going to be 1 now. So I started with this as 1/3, and then 2/3, and then I have 1, and then I can keep marking like that, 1/3 after that, 1/3 after that, and 1/3 after that. That makes me reach 2. And then same in the horizontal direction, so that's going to be my 1, and so on. So what did we do? We try to draw the picture so that the details of it are not lost in at the tip of our pencil and being so small as not to show itself. So my y-intercept is 1, so let me use a different color. So y-intercept is 1/3. And then slope is 2/3. So that means if I go 1 unit up, excuse me, 1 unit to the right, then I'm going to go up 2/3. So 2/3 plus 1/3, that makes it 1. Or think about it like this. If x is 1, then 2/3 plus 1/3 is 1. So this is at the location 1, 1. So this is not too unfriendly. So I have 2 points of my line. Now I can draw the line. So this is going to be the line. So that was my y-intercept. And then here I'll mark the x-intercept of it, which we found out is at minus 1/2. So minus 1/2 is where the y is 0. That becomes a picture of this problem. Okay, so graphing problems, when the numbers are friendly, it's just straightforward. Otherwise, you have to be careful in choosing your units and making sure the details are not lost by inaccurate choice of dimensions and so on. For the next question, I'm going to pick on this problem 27, a mix of equation of line and something you should remember from your previous classes, which is how do you measure the distance. It says find all points on the line y is equal to 2x plus 1, which are 4 units from the point -1 and 3. What does that mean? First, when we encounter a problem like this, we try to draw a picture to see what this whole thing is all about. So I have 2x plus 1, 2x plus 1, so y-intercept is 1 and the slope is 2, so 1 unit to the right is going to take me up by 2, or at the 1 I'll be at 3, so I'll have a graph looking like this. Let's draw it in a more bright white. So this is the graph of y is equal to 2x plus 1. Then what? Then we have another point, coordinates -1 and 3. So where is -1 and 3? So let's just go ahead, approximate it, perhaps -1 and 3. Yeah, 1, 2, and, well, 2 and 3. -1 and 3. It says find some point here, or find all points here that are 4 units away from this. Well, what does that mean? Well, when we draw a straight line from this point to the line, that line segment is going to have a length. We want that to be 4. We want to be 4 units away. Of course, if I'm down here, I am as close as I can be. As I move away, my distance increases and increases and so on. The question is, does that distance ever become 4? Well, we notice that if it does, then very likely it's going to happen on the other side as well. So the question is, which one of these lines is going to be, so which line segment is 4 units long? Find, is it like this point? Is it this point? Is it this point? Where is it that my distance from that -1, 3 becomes 4? Well, it could be that there is no such point. Like if I say which point is it where the distance is 0, of course there is none. If I say the distance is 1, probably there is no point that's so close to this. So this is like the closest we could get to -1, 3. Let me call that so that I can have an easy way of referring to this. Let's call this point P. And let's call, so it's common to name things so that we have an easy way of referring to them. So I have a line L, I have a point P. I want to find some point on the line. So on the line, I go ahead and call my point, say Q. The question becomes, is there a Q such that the distance of P from Q is 4 units? Well, what do you remember about measuring distance of points? Let's go ahead and review that from say algebra 1 and such, and then we'll be ready to answer this question. So let me go back a little bit and open this issue up for you. If I have one point here, say point 2, 1, and I have some other point here, and suppose this is 6 and 3. If I ask the question, how far apart are they from each other? How long is this distance? Well, how do we answer that? And the answer to that is going to come from most famous theorem in mathematics, which is the Pythagorean theorem. Is that right? Pythagorean theorem says if I have a right triangle, well, I don't have a right triangle here. What do? You make it, draw a line horizontal, draw a line vertical, and they are going to be perpendicular to each other. And then we remember that famous theorem that if you have A, B, and C, the sides of a right triangle, then A squared plus B squared is equal to C squared. Back home, they used to call it the bride theorem because it was the most beautiful theorem. Whatever. So, well, how do I find the legs of my triangle here? Very easy. Say, well, how long is this one? Well, you're going from x coordinate 2 to x coordinate 6. So the distance of these two is 4. And how about the going vertical? Going vertical, you're going from 2, 1, from 6, 1, this is a 6, 1. You're going to 6, 3. How much have you gone up by? Well, you have gone up by 2 units. Okay, so the x of this and the x of that, they are 4 units apart. The y of this and the y of that are 2 units apart. So the size of the legs of my triangle are 4 and 2. So what's the hypotenuse? I say, let's call the hypotenuse c. C squared is going to be 4 squared plus 2 squared. So that's going to be 16 plus 4, which turns out to be 20, and c is plus or minus square root of 20, and a positive number is our answer, becomes square root of 20. So this becomes the hypotenuse of this thing, and we find the distance that way. Okay, so that was the preliminary material for this problem. How does that problem show itself here? Here I say, well, I want to choose a point here. How do I choose a point? Well, there are infinitely many of them. How can I refer to all of these points? Well, I don't know which point you want to choose. So x of it will be some x. We don't know. Well, if you are choosing your point on this line, if Q is on this line L, what's going to be the y of that point? Well, that's the advantage of this equation. If you have chosen the x, then the y of it is 2x plus 1. So that is 2x plus 1. Okay, what now? Well, now we ask, what is the distance of this from that? What did we learn here? Subtract the x's, that give you one leg, subtract the y's, that gives you the other leg. So subtract the x's, that means the first dimension here. This is x, that is minus 1, I subtract them, so x minus 1. That's one leg. I take that and square. Plus the second coordinate. In the second coordinate, take those and subtract them as well. So it's 2x plus 1 and then minus 3. Is that right? So I took the first coordinate, subtracted them, and I have to square. Second coordinate and the second coordinate, subtract them and then square. What is that going to give me? Well, that's supposed to give me the square of hypotenuse. What hypotenuse do I want? Hypotenuse, I want it to be 4. So this has to be 4 squared. So let's write this has to be 4 squared. Let's clean this up. So this becomes x plus 1 squared. And the other one becomes 2x minus 2 squared. That has to add up to 4 squared. Now, algebra to the rescue. What do? X squared, so x squared plus 2x plus 1. Let me remind you, if you have a plus b and you want to square it, That is a squared plus 2ab plus b squared. You remember that? So square of the first, square of the last, and twice the product of the two of them. We do the same thing. 2x squared. Well, that's going to be what? 4x squared. Twice the first and the second. 2 times 2x times minus 2. All of it boils down to minus 8x. Second item squared, minus 2 squared becomes plus 4. And right hand side is my 4 squared, which is 16. Now we have to clean up. So x squared and 4x squared is 5x squared. 2x minus 8x is minus 6x. 1 and 4 becomes 5. Bring 16 to this side, becomes minus 11. So that's a quadratic equation. Do we remember how to solve that quadratic equation? Okay, so let me quickly review quadratic equations for you as well. If I have ax squared plus bx plus c equal to 0, what is x? X is minus b plus or minus radical what? Does everybody remember? B squared minus 4ac divided by 2a. So quadratic formula is our fallback position in case the numbers are unfamiliar. In this case, you could also factor it, but perhaps that takes just as long. Let's go ahead and solve with quadratic formula, and then we come back and see what the answer is. So x becomes minus b. b is coefficient of x here, so minus 6 is 6, plus or minus b squared, so minus 6 squared, so I have to write minus 6 squared, minus 4 times the first and the last numbers, and then divided by twice the first number. So let's clean this up. X becomes equal to 6, either plus or minus. Minus 6 squared is 36. 4 times 5 is 20. Minus minus becomes plus. Becomes 20 times 11, 220 over 10. Now x becomes 6 plus or minus square root of 256. 256 is our lucky number because it comes out of radical and becomes our friend. So it's 6 plus or minus 16 over 10. So if you add them, 6 and 16 becomes 22 10, or if you simplify, 11 fifth. If you subtract them, 6 minus 16 becomes minus 10 over 10, which is, well, just minus 1. So what I got here is that x is either minus 1 or x is 11 fifth. What were we looking for? We were looking for a point. Find all points. Well, how do you say I found the point? You say I have an x and a y, so I have to give an x and a y. So I got my x. How do I find my y? What do you say? How do I find my y? Well, I'm on this line, so it means my y is 2x plus 1. So that's what I'm going to use. So in all of these cases, the point that you're finding is on that line. So its y is twice x plus 1. Twice minus 1 plus 1. Our y for this becomes minus as well. And twice that will be twice, well, that plus 1. So 22 and 5 makes a total of 27 fifth. So my point, I have to clarify what are my points, minus 1 and minus 1, or 11 fifth and 27 fifth. So the point Q that we are finding, Q is either this one or that one. So that means on this graph, I'm going to go at -1, like somewhere around here. And the other one was what? It was 11/5 and 27/5. So that's almost like 2 and 2.2. And this is 5.4, 2.2, and 5.4, somewhere around here, perhaps in this picture. So you notice that we went through quite a bit of preliminary material. We reviewed Pythagorean theorem, we reviewed how to solve the quadratic equation, and we solved an example of a quadratic equation here. Now sometimes you might get lucky and you might think about how to factor these equations and find your solution that way. So this one you can think about how to factor it by either breaking this up into two pieces or other methods that you might have learned in high school. Okay, I am gonna give a bit of an explanation on how to solve this quadratic equation in another method that your high school teacher might have covered for you. This is optional. What we have done here is the default way of doing it, but sometimes factorization also comes at handy, and let's see how do we factor these type of problems. So let me just open a little bit of space here and try to explain it. So the question is, how do you factor this expression 5x squared minus 6x minus 11? If it can be factored, how do we do it? There's no guarantee that a polynomial can be factored into convenient numbers, but every now and then it does happen. So what do we do? Take the first number and the last number, multiply them. So 5 times minus 11, so that's minus 55. And then pick the other number as well, so minus 6. Give me two numbers such that the product is minus 55 and their sum is minus 6. Which two numbers can you give me such that their product is 55 and their sum is minus 6? Well, 55, you can all write it at 1 times 55 or 5 times 11. 1 times 55 is not going to give us such a sum, so we are going to go after other one, 5 and 11. Well, one of them has to be positive, the other one has to be negative, such that the product is negative 55. So which one of them do we choose? So if I choose 5 and minus 11, so the product of these two is minus 55, and the sum of these two is also minus 6. So far what did we do? Take the first and last number, multiply them, pick the first middle number by itself. Then we say find two numbers. Find two numbers such that the product is minus 55 and the sum is minus 6. Well, if we go through our head and say what numbers multiplied is going to give 55. It's only 1 and 55 or 5 and 11. Now we have to fix the sign such that their sum becomes minus 6. The only way that we can do this is 5 and minus 11. Then what? Then we write that expression 5x squared. Instead of minus 6x, I write it as 5 minus 11x. Ask why do you do that? Well, first of all, 5 minus 11 is minus 6, so we haven't changed anything. Now I take that and break it up. 5x squared plus 5x minus 11x minus 11. Now I do factorization by grouping 5x times x plus 11 minus 11 times x plus 1, and then minus 11 times x plus 1. Then what? Well, x plus 1 is the same, so I can factor it. Factor x plus 1. What is left? What is left is 5x minus 11. 5x minus 11. So if your objective was to solve this equation equal to 0, now your objective is easy to accomplish because you're solving this equation. Now this is factored. You say either the first factor is 0 or the second factor is 0. So you say either 5x minus 11 is 0, in which case x is 11/5, or x plus 1 is 0, in which case x is minus 1. And lo and behold, these are exactly what we got here. So we recovered the same thing, but with somewhat an odd way of factoring a quadratic. But every now and then the factorization comes in other areas as well. So we practiced that problem as well. So I understand that this problem was a little bit more than everything you bargained for so far, but the good thing is that we've practiced Pythagorean formula, practiced squaring identity, this one, practice how to solve quadratic equation, practice how to factor some of these peculiar quadratic equation, and we also drew the picture in which we hopefully understood what are we after. Okay. Now for next problem here. Okay. The next problem is what is typically referred to as a word problem or application problem. Here it says a landscaping company charges 45 per cubic yard of mulch plus a delivery charge of $20. Find a linear function which computes the total cost C in dollars to deliver X cubic yards of mulch. So we are practicing how to make a function. As we said, we are going to talk about function more extensively in the next lecture, but here we are just making that linear function or linear formula for this situation. So what are our ingredients? We have a delivery charge. So regardless of how much you order, the delivery charge is a delivery is a fixed amount. Well, assuming that you're not delivering 1,000,000 tons of mulch, just a reasonable amount, delivery is $20, and the mulch itself is 45 per cubic yard. Now, if you want to order perhaps 2 cubic yards or 3 or 5 or 10, so the amount that we are ordering is we are going to order X cubic yards of mulch. So how much is it going to cost? So it says right this the letter C standing for cost. So cost is going to be what? If I'm ordering 2 cubic yards, and then 2 times 45 is going to be $90 plus 20. If I order 3 cubic, that's 3 times 45 plus 20, and so on. So in general, it's going to be 45 per cubic yard times how many cubic yards you are actually ordering, and then for delivery of the whole thing, they are going to charge us 20. Okay, so our functions or the equation for the linear equation that describes the cost is C is equal to 45x plus 20. In mathematics, our variables are not assigned any meaning, so they're generic, so they're always called x and y and whatever is fashionable at the moment. In most applications, your variables mean something. So here cost is shown by c, so we remember what that one refers to, and perhaps the the no, the problem is that the amount you're the amount you're ordering is cubic yards. So if I use the letter C again, it's going to be a problem. If I use the letter Y again, that's going to be another problem. So perhaps if you want to make that memorable, uh, so if you want to make it memorable, so maybe you want to refer to it as 45M. M is going to be the amount of mulch you are ordering. So the amount of mulch you're ordering. So you choose your letters so that it's memorable in your practice. In mathematics, the variables are a single letter. So letters of alphabet A through Z, or capital letters A through Z. Sometimes some Greek letters like alpha, beta, gamma, etc. get to be used. In most application, people just use the full word or an abbreviation of the word, which is going to be more than one letter. So you have to be careful if you, for example, if you write cost. Well, everybody understands that's the word cost, but somebody could make a mistake of thinking this is C times O times S times T, and that would be a weird mistake to make, but it is a possibility. So when you are naming your variables, you have to be very careful about what is your naming convention and what you mean by the variable that you have in front of you. Okay, so I'm going to put one more problem here for conclusion. Let's see if this works. Yes. Okay. In on-demand, publisher charges $22.50 to print a 600-page book and $15.50 to print a 400-page book. Find a linear function which models the cost of a book C as a function of number of pages P. Interpret the slope of the linear function and interpret C of 0. Let's see, what does that mean? So this is another practice on linear equation, slightly different format. Let's see, let's write it down. So I have two things in mind. One is how many pages I'm printing and how much is it gonna cost me. So I know if I have 400 pages, it's going to cost me $15.50. So that is cost in dollars. And then if it is 600 pages, my cost increases to $22.50. So what is it that I want? I want the cost. So cost. I want to write it in terms of number of pages. So the idea is, well, if something was 300 pages, how much is going to cost me? If it was 1,000 pages, how much is going to cost me, and so on. We want to make a educated guess out of the numbers that we have. So this is P is for pages and C for cost, and we want to find C in terms of P and make sense of the formula that we got. Well, let's go use the idea of graphing that we had. So idea of graphing was to have the two axes. So now my horizontal is P for pages, my vertical is C for cost. My pages go from several hundred, so it wouldn't make good sense to say this is 1, 2, 3, and so on. You don't have a book with one page and so on. So the idea right now would be to like use a unit that makes good sense. So for example, I might say this is 100 pages. So we have to use our unit in a sensible way. 100, 2, 3, 4, 5, 6. So at 400, I have 1550. So in the vertical axis, perhaps I will have $10 and $20 and so on. So 1550 somewhere here, just approximately drawing something. And at 600 we have 2250. So 2250 is somewhere here. And then we want to find out how cost behaves in terms of page. So we are going to assume that the cost increases linearly with how many pages you got. So there's a linear function going between these 2 points, and we want to find that function. Okay, so this is similar to a problem we did last time, where you have 2 points of a line and you want to find the line. What was the idea? The idea was to figure out m first. So our m is going to be a rise over run. What is my rise? Well, my cost has gone up from 1550. I went up to 2250. When my number of pages went from 400 to 600. So that would be $7 extra for 200 pages. Or if you want to divide it, you can get 3.5 divided by 100. Let's write just 7 over 200. Perhaps it's a little bit easier to see what's happening. How did we write the equation of a line? We said y minus y of a given point. Well, now instead of y, I have c. c minus 1550. So here, suppose I have a point with coordinates p and c. Instead of x and y, they're called p and c. So I say c minus c of this point, say c minus 15.5 over p minus 200. That's the slope. That slope has to be same thing, 7 over 200. So c minus 1550 is 7 over 200 of p minus 200, or c is equal to 1550 plus 7 over 200 of p minus 200. Excuse me, I made a mistake here. Let me correct myself. This was 400. Sorry, let me write it in red so that the correction is clear. This was okay. So c is 1550 plus 7 over 200 of p. 7 over 200 times 400 becomes minus $14. To simplify this thing, becomes 7 over 200p plus 1.5. So what's the slope of this thing? Slope of this is 7 over 200. What does that slope mean? It costs you $7 for 200 pages. Perhaps this might make more comfortable sense if you write it like this: an extra cost of $3.50 per 100 pages. Or if you want to actually divide it, go ahead and be my guest and divide. So this is dollar per page. That's how much extra it costs if you increase the number of pages. What is this? So if you had no pages at all, if p was 0, your cost will be 1.5, meaning just to place the order, just to go to store and place the order, the fixed cost of this thing is $1.5. So in function notation, again, we are going to see this thing later on. We say cost of, then number of pages I put in for a cost of P is 7 over 200 plus 1.5. So cost of no pages at all, I forgot the P here. Cost of no pages at all here is just 1.5. So the meaning of this thing is the cost of order. Cost of ordering anything. Your basic cost is $1.50, and then per page they charge you like 3.5 cents. So 3.5 cents per page. So that's the meaning of the ingredients of your problem. Again, an example of linear equations or linear functions that we practice. Now try to do as many problems from this section as you can. Your solution, the solution is available to you. You can double check yourself to make sure you're on the right path. So what did we learn today? Linear functions and equations. We learned about their graphing and various type of word problems related to that. So until next lecture, good luck and God bless.